Welcome, students, to the first part of lecture series of Analog to Digital Converters in our coursework of Analog Circuits. Myself, Dr. Kirti Vyas from Arya College of Engineering IT. So, let's get started with the lecture. Today we are going to discuss about simultaneous A to D converters. These are also known as flash type converters, and these are one of the fastest converters which are available in the market. The slide shows the block diagram representation of simultaneous conversion technique. Now let's talk about this particular technique. As you can see, there are three comparators C1, C2 and C3, and here three comparator circuits are used for two input bits. Each of the three comparator has a reference voltage derived from a precision reference voltage source. A potential divider network provides 3 by 4V, half V and 1 by 4V to the respective comparators. The other input terminal of each comparator is driven by unknown analog voltage, which has to be converted to its digital value. The comparator will be on if the analog voltage is more than the reference voltage. If none of the comparator are on, the analog input will be almost lesser than or equal to 1 by 4V. If C1 is on and C2 and C3 are off, the analog voltage will be between 1 by 4 and 1 by 2, which is shown in the second row of this different possibilities of comparators getting on and off. Third row talks about if C1 and C2 both are on and C3 is off, the analog voltage will be between half and 3 by 4V. If all the comparators are on, which is the last row, the analog voltage will be greater than 3 by 4V. So, there are four output conditions. The analog input voltage can be resolved into four equal steps. These four output conditions can be coded to give two binary bits of information. The comparator outputs can be encoded to give 2-bit output. The encoder which is used here is a logic circuit consisting of AND and OR gates. This is how a flash type of comparators work. The advantage of this particular circuit is that the speed of conversion is higher for simultaneous A to D converter, and due to this only it is known as flash type. The disadvantage are that there there is requirement of 2 raised to power n minus 1 comparator for n bit A to D converter. This means the 3 comparators are required for 2 bit and 15 comparator will be required for 4 bit A to D conversion. The second disadvantage which can be listed is that the resolution is poor. It means voltage lesser than V by 4 cannot be detected in this particular case. Now we move to our second A to D converter. This type is known as single slope A to D converter. This particular slide shows the architecture of single slope A to D converter. As we can see, it is comprising of a comparator. The input to the comparator is the desired analog input, which has to be converted to its digital format, and this is applied to the non-inverting terminal of the comparator. The next input of the comparator is coming from a ramp generator, which is going to generate a ramp signal. The output of the comparator is fed to a clock circuit, which is going to produce a clock only if a comparator gives a high. The clock is going inside a counter. That means if the clock will be high, it will be initiating the count further by 1. The output of the counter is provided to the latches, which gives the binary output for our applied analog input Vi. We also have a control unit which is having a control logic, and it is giving commands to the counter so that the counter can be made clear as required. It is also giving the command to the latches to enable or disable a latch, and also it is having the capability to reset the ramp generator so that it could be made ready for the next A to D conversion. Now let's look at the working of the single slope A to D converter. As the analog input is given to the circuit, the ramp starts generating the ramp signal, and till the time the applied input is greater than the ramp generator, the comparator is going to give a high, which is fed inside a clock pulse, and the clock is initiating the counter. This process will keep on repeating till the analog input is greater than the applied ramp, and the counter will keep on counting. Next, at the time when the ramp generator output, that is ramp signal, becomes greater than your analog input, then the comparator will give a low. This will disable the clock and the counter will stop counting. Now, this particular output from the latch will be displayed as A to D conversion of the applied input. Now, the control logic will enable the latch to give the output. It will also give a clear command to the counter and reset the ramp generator. And this is how it is going to work. After reset, the ramp generator will be 0, the counter will be 0, and it can do the function for the next A to D conversion. I have taken the material from a particular book of LIC by Dr. Lal Kishore, and I also thanks the e-content of our known website of IIT Bombay in order to make these slides.